The screen is visible now. One of you just confirm me. Is the screen is visible from my side? Ganesh,
Yes, sir.
screen is clear, no? From my side.
Yes, sir. Yes, sir.
Today we'll discuss the remaining half chapter from the fifth module. It is last class we completed the concentrating collectors, and one of the simple example we took to discuss about concentrating collectors. Today we'll start with the last part, that is economic analysis of solar energy. So nowadays, if you talk about only the energy or the new technologies or any changes in the technology, whatever, the final thing comes in mind is what is the economic of that energy or how to use that energy so that one can benefited by the economics, because economics is a very important part of this energy conversions. So coming to this last part, so until and unless if I clarify about you or about the solar economics from this renewable energy source, until that no one is interested in such type of energy systems. So once the economics of such topics are very clear, or how it is economically viable or the benefit to the society, then only the people will be attracted. So to keep this in mind, the topic is involved attached to this fifth module, that is solar economics. So personally, I also believe that this such type of topics are also very important, because nowadays you can see solar car or electrical car or biodiesel sorry, hydrogen vehicles. You see, whenever the cost of the fuel, many people are very much uh, thinking about the cost of the fuel, cost of the vehicles. Also, apart from this, they also need the power as well as the maintenance cost should be less. So like this also in solar energy, whatever we discussed until now, or as a renewable energy source. So here the economic part is also very important. We need to prove these type of technologies whether they are economically viable, or one should invest huge amount in the initial stage or not. So coming to this part of uh, discussion, I have involved or added all the theory part in this topic so that you can directly refer this PPT itself for your discussion. And later we'll take some of the problems so that one can understand how this solar energy is also very important, and what is its economic part, how it is viable, and what is the advantages. So one person can go with the solar energy as an alternative source for electricity or the common energy applications. So in that matter, I've taken all these details in this PPT itself. So coming to this first part, now any system if you take a value of a system utilizing like solar energy or any renewable energy sources, it involves two important economic parameters. So that is one is initial cost and its annual operating cost. So if these factors are very clear, then an investor can go with a solar system or any other renewable energy source system. So that initial cost or the initial investment should be very clear for the system. So it may be a direct or indirect utilization of solar energy. Because what happens, directly if you go for solar energy itself, what will happen is one cannot build 100% system with a solar system. Uh, so in such cases, what will happen is, in any case, if the high power or suddenly a low power is required, in such conditions we cannot control the system properly, or else depending upon the weather. Why? Because these renewable energy sources are all dependent on the weather conditions of the seasons, are also on the depending upon different days also. So keeping that in mind, one can conclude there. the solar energy cannot be obtained throughout the year, 24 by 7, then also the conversion rate along the given life of the system is not 100%. And for a maximum power required, we cannot depend only on the solar energy system. So in such conditions, one can go with the auxiliary systems, maybe grid connected electricity or solar with the help of other renewable energy sources. We can connect the solar system with other renewable energy systems, or it may be a hybrid system also. Means combination of many such type of electrical or energy system, so that anytime if the maximum power is required for a home, so directly can use solar as well as grid connected electricity or with other systems. And whenever if the medium or very low energy is required, in such cases you can go with this solar system itself, so that you can save some energy. So in such conditions, the cost of an energy system is usually considered in two parts, that is initial cost and the annual operating cost. Okay, so as is evident by now, solar system is characterized by a relatively high initial cost. So all of you know that the construction of solar system may be a thermal application or for a PV system, the material cost itself is very high. And keeping in that mind, also the conversion rate or the efficiency of these systems are also very less compared to the conventional energy sources. So this one should keep in mind that high initial cost will be there for a solar energy system. That is one part, high initial cost. But what about the life of this system and the uh, returns or the profit, what we are going to get in the long term? That we need to focus later. So that high initial cost will be there. This cannot be taken out. And a relatively low annual cost. So annual cost in the sense, here we are not using any mechanism like an engine or a turbine in the thermal power plants. Like that, we are not using any moving parts. So the complete entire system is a static system without any movements, without any mechanisms. So, and also we don't need any extra fuel. It should be purchased in between to run some mechanisms and other things. And also for the maintenance, whenever you see, once it is built and made a system, only thing is to clean. So every year or a monthly or a 6 monthly basis, we need to clean the system. So only this is the annual maintenance cost, or maybe some battery system or some auxiliary systems other than the PV cell or the flatbed collector or the concentrating collector. Other than cleaning, I may tell you like battery replacement or some wiring connections or some auxiliary systems which are running on uh, electrical or some other fuel systems. Those auxiliary systems need some annual maintenance cost. So that may be relatively low. Then coming to other hand, an energy system using a conventional energy source like fossil fuels is characterized by a low initial cost. So all of you already know. So whenever you think about purchasing a diesel or petrol vehicle, all of you think about going for a diesel engine because fuel cost is less. Okay, but the initial cost is high. So similarly here, even if you think about the petrol vehicles, initial cost may be very less, but the running cost will be very high because of the fuel cost. But if the non-conventional energy source, if you think, initial cost will be very high, but the running cost will be less. So like this, all the energies will be having some different economics. So that you have to keep in mind. So always a renewable energy source or a solar energy will be having very high investment in the initially, but the running cost will be very minimum. So once you cross the payback period or the net zero investment or the profit, after that you can hope some profit over these type of renewable energy sources. So once I discuss about these things, the people will get clarification about whether to buy or whether to go for the renewable energy sources or not in the long term. But initially, many people will think because of high initial cost or investment and with low knowledge of the technology, one may not think about going for the renewable system. But once any person is clarified in the economics, then he will definitely will decide what energy system I can use for my home or transportation or any other applications. Then their economic will come into picture. So thus the economic analysis of an energy system is very important in such situations. So anyhow, you may tell me, sir, what about the technology improvements? What about the reducing the cost of the materials? Or how about the improving the efficiency by different technology and other things? But nowadays, if you see, even the research we may talk, the research in these fields is very less. That is one thing. Then technology and other things, it is until now it is improved, not a big issue. It is improved. But the conversion efficiency is also less. So in that field, they have to work more. And also talking about the reducing the material cost of the improving the technology. Here, what happens is initially the materials required for PV system or the thermal conversion of solar cell, their material cost itself is very high till now. So reducing that cost is very difficult, but we can go for alternate materials. So that also one can think of. Then improving efficiency in the sense the mechanism or some other materials, as I told, or the manufacturing process itself. One need to change the manufacturing process itself with changing the material properties. Then one can achieve more efficiency of conversion also. Okay. So this is about solar energy. So after discussing all these things, one can think of whether it is viable or not. So whether it is viable with scientific aspects or with technological aspects, or whether it is ecological or not. Because if I tell ecological means we need more land, okay, and also because of the thermal collection or the conversion, land requirements are more, and also the material required is also more for such systems. Because if you see, apart from the PV system for a given area, okay, the conventional thermal power plants are more efficient. So that in a given area, whatever the megawatt or the gigawatt power is generated by the normal conventional power plants is very high compared to these PV systems, which also directly convert the electricity without any moving parts. But still, we have to compromise on the land also or the area required and the initial high costs. So here we need to talk about the economical viable also. Whether it's viable or not. So apart from this, if you take, you can also think about wind, tidal, wave, okay, or ocean, or any other type of energy systems on the similar case. So next, coming to the details of this initial cost and the annual cost. So initial cost of the solar system is the cost of buying the equipment and installing. So whenever you go for any standalone systems, always we have to first buy the system. So that is the uh, fixed cost. So at which time we are going to buy the system and we are going to install it. And for installation also, we need to spend some land, money, as well as human effort. So that installation cost is also coming into picture in this initial cost. So here generally it is the sum of two components. So in this initial cost, we are going to spend on the cost based on fixed materials and cost on the variable uh, components. So the fixed cost refers to the cost of, like say for example, a device which is used to convert the solar light to thermal or light to power, like sensors or devices in home, or some control equipment which are connected to the home to supply the power. So like that systems, if you see on the installation or standing these systems, we need some fabrication also. So these are like some fixed costs which we cannot overcome. Then variable cost, if you see, these are proportional because these are not fixed always. These depend on the time as well as depending upon the material, depending upon the expertise of the people, and also depends on the output. So in this case, solar thermal system, the variable cost includes cost of the collectors, because collectors, we need to decide about the material, we need to decide about the area and type of the fluid, what is flowing inside the flat bed. Normal water, if you take, you can go by any material without corrosion. If you go by oil and other things, so where corrosion is not possible, you can reduce the material cost. But oil cost may be increasing. So like that, you have to make the compromise. Then the storage system. Storage system may be variable depending upon the requirement of 200 liter or 100 liter. Then the heat exchangers. Okay. So like this, these are the variable costs where depending upon the requirements or outputs, we need to decide which type of connector is required, which type of fluid you have to flow inside, what type of storage and heat exchanger system is required. So these are the few examples of thermal systems with variable cost. So and then installment cost also, or the installation cost is also different, depends on the different expertise of the people. So these variable cost is proportional to the corrective area, okay, and also the fixed cost is essentially dependent on the corrective area also. So like this, some points are given here, and also to reduce these costs like variable or fixed costs, even some promotional incentives can be offered by the companies which are selling these systems, or central or state government also can exempt some excise duty or the insurance they can give us, and also some sales tax can be reduced or some discount. Initially, they can give some discount, thinking of environmental safety and ecological balance, okay, all those things, or the pollution also, controlling the pollution. So keeping these in mind, government can also reduce its different taxes or financial subsidies or the loan at very low interest can also be given by the government also, or the banks or some big companies can also provide to their employees, so that many people can directly go without thinking much, without investing directly by their own money. And later, it is also seen that for a period of 10 years, there is no tax or the no, what is that, different loan, what is the interest is there. For 10 years, there should be completely exemption. So such type of system is also implemented in India. So recently, what is happening, I also not gone through that. You can just check online. So for latest for a solar system, for a renewable system, what government is giving the benefits with loan or taxes or the payment time up to 10 years or 20 years, the owner cannot pay anything. But later, once he gets some return on investment, then he can start paying the loan, or he can start paying the grid connection taxes. So these are the different benefits available nowadays, so that customer can think of going for the solar systems. Okay. Now next is the annual cost. Annual cost, all of you know, in conventional systems, always we think about the fuel cost and maintenance cost. But here in the renewable systems, we have very low annual cost because of the only cleaning and maintaining the auxiliary sources. Okay, in such systems, very low annual cost will be there. Maybe some taxes will be there because of after return on investment, once the owners start paying tax to the government or very minimum loan to the companies. So in that case, we talk about this annual cost. Okay. Then apart from this, you can see here the net annual cost of a solar system that can be given as, or it can be found out from cost of the fuel or electricity consumed by the auxiliary system plus repayment of the loan after return on investment, or depending upon the bonding between the customer as well as the company or the banks. Depending upon that, the repayment of the loan will be there, that amount, and maintenance charges of the small taxes or the local taxes required for the municipal or the state government, that should be paid, and minus tax deductions, or minus you can tell the profit earned by the system. Okay, so keeping these in mind, whatever the costs you are going to put in this system, okay, to maintain the auxiliary system or to clean the system or maintain the system on a yearly basis, and loan whatever you are paying, then whatever profit you have made or the deductions what government had provided you. So keeping this in mind, if you take all the sum of the costs, I can find out the net annual cost of a solar system. Any doubts up to here? Yes.
No doubt, sir.
Okay. So like this, we discussed about initial cost and annual costs, how it will be found out in the solar energy system. It will be similar to the other renewable sources also. Okay, it's not different from all different renewable sources. All renewable sources, we are going to find out the economics based on these systems. Okay, so next we'll see some of the other definitions. Also, if you see the solar energy performing same duty but using only conventional energy. See here. Now here what we are going to do is the loan amount what we have taken and what we are going to pay, the percentage of extra what we call the percentage of loan interest. Sorry, the word I am not recording very easily. The interest on the loan what you are paying. So that amount, some people are also going to compare with the fuel cost if you are using a conventional energy system. If it is less, then also the people may tell it is economically viable. So it is also depends on the thinking of the people also. Different people think in different ways. Say for example, I may think that I can take some loan now, I can pay the interest after some days, and before that I can put that same amount in the fixed deposit or some post office RD this one, or I can put the money in the share market and I can get some profit. If that profit is going to be remained with me, even after paying the interest of the loan taken from other company. I hope you are getting. So if this is happening, or if the customer is always in the profit with some of the systems, then always he prefer to go with this system if the economical viability is understood. So like that, here also for the conventional system, annual cost of the equivalent conventional system is equivalent to cost of fuel or electricity consumed. But if your grid is connected or if it's a hybrid system with solar energy on your roof, in such conditions, if your profit is more, then your energy what you are spending on the conventional fuels of the conventional energy, then you can claim that a solar energy on the renewable energy is a economically viable system or it is a profitable system. Okay, now coming to the different definitions, as I told, first one is the annual savings. Now we are going to talk about savings now, how to find out the savings for the solar or the uh, different renewable sources. In that, we are going to discuss about different definitions. First definition is the annual savings. First is the annual savings. That is, annual saving is the different factors, like say for example, savings on the fuel or electricity. So saving means now I am telling you about solar energy I'm using. So I am going to save some conventional fuel on the grid connected electricity. I am going to save some amount. So how much it is saved? Minus the repayment on loan taken for the solar system. Okay, that loan interest or the amount what you are paying, that you have to take minus sign, minus the maintenance charges of the local taxes paid plus tax deduction. So if you take all the sum of these different costs, then I can tell if it is positive, I can tell it is a savings in annual. Is that clear? So considering a standalone solar energy system installed for a application like water heating, water space heating, or a electrical conversion system, in order to evaluate the economical viability, we are interested in calculating different savings. So in that one saving is annual savings. So annually, if you have saved means your net amount, if you take all these values and if you take the negative or positive summations, then net value should be positive. That is, whatever the amount you have saved from the fuel spendings, like if you have gone for conventional system, what was your spending monthly or annually? What that total you have to pay? That is the savings. Because that amount you have saved now, because government is not paying you to give the electricity bill every month. Because you yourself generating the electricity on site as well as you are using the thermal energy from the home roof itself. So government cannot take your electricity bills every month. So that is the saving. minus repayment on the loan, because this is going from your hand. So that loan interest what you are paying or the amount what you are paying, that will become minus, and minus maintenance charges, very low maintenance charges, something very low taxes. So that is minus. And now, what is the benefit given by the government on interest or in the discounts, or what are the benefit with depreciation or inflation of the system is given? That all considered under tax deductions. Okay, because as I told you, the government of the different companies, if you go for renewable systems, they cannot take the interest for long term, for 10 years or 20 years. They are not taking the interest. So that is also one benefit. That is a tax deduction benefit. One more benefit is nothing but whatever the discount given by the government while purchasing, or yearly the electricity bill concession is also given from the grid connected systems. So these all concessions I have considered as tax deductions. Then coming to the cumulative savings. So I think time is 12:41. Another 5 minutes I will discuss with this slide. We'll stop the class here and we'll discuss about the paper. Okay. The next is the cumulative savings. As the name itself indicates, it is a cumulative, continuous savings. Okay, the continuous saving in the sense for a certain number of years. Okay, say for example 10 years, 20 years. It is the sum of the annual savings over the period. So what is the annual savings you have found out now per year? That into number of years. If you take that becomes the annual savings over the n years that is taken, plus the cost of an equivalent conventional system. See here, now what I am finding is what is the saving done for a given number of years. It's nothing but annual saving. Okay. For given n years, what is that annual saving? It is a cumulative savings. I hope you are getting. So annual saving I'll find out for 1 year, I'll multiply with number of years. Say for example, I want to find out for 10 years, I'll multiply this with 10 years. So I found out for 10 years what is the annual savings. Okay. Now, what I'm going to compare with this is the cost if I would have taken one conventional system itself. Say for example, one battery system connected in home, or I have connected the home itself to the grid connection, or in place of electrical vehicle, I would have used for a petrol engine itself or petrol vehicle itself. So that cost of that equivalent conventional system, okay, minus initial down payment made at the time of installment of the solar system. Because whenever you see any vehicle, if you take, the down payment will be there. If the cost is very high for a person, he can claim for the down payment and later he can pay with the interest with equal installments. So similarly here what they have done, they have taken the annual savings, also the sum of cost of an equivalent conventional system. For the same power, what is the cost if you would have spent on the conventional system? That cost they are taking minus the down payment what you have paid in the initial stage. Okay, so all these factors if you consider, that I can tell it as it is a cumulative savings. So if this factor is positive, then one can claim the solar energy system is a economically viable system. Okay. So important is you have to keep in mind what all terms here are added and subtracted. That is very important. Here also same thing. I'm going to add all the annual savings, all the cost uh, put for the conventional system minus the initial down payment what is done for the solar system. Because why I'm taking minus of initial payment? Because initial payment is very high for the solar system. So this you cannot compare with the conventional system. So in such conditions, what I'm doing is annual solar savings I'm doing for given years, and initially if I taken the conventional system, what is the cost of that conventional system for given 10 years? Okay, minus this initial installment. Okay, if this is positive, then cumulative savings is also positive. Next, last one we will discuss today, that is life cycle savings. This is very important. Actually, life cycle savings we have to discuss after the payback period. So payback period, what I will tell briefly today, so that to understand the life cycle savings. The payback period is whenever you purchase any system and after paying its loan, interest, okay, after running it for a long time, later you will get some profit because it is going to generate some energy or some economics from that system. Say for example, I'll take sketch here. Easily. Here you can see this example. See here, the initial cost what I told is this is the initial cost. Set number 4,000 is the cost given or set for returns taken from the system. So once the returns crosses, okay, the investments, investment is in red color. What is the initial investment for the solar system? You keep in mind that I have purchased one solar system for $4,000 or euros or 4,000 rupees. I have purchased. Now, after what time I am going to get the benefit from this solar system? Okay. So, say for example, now it is running with a grid connected system. I am using electricity from the grid as well as solar. Both, whenever the grid connection is not there, I will run the solar system. Whenever the solar system as well as grid both are there, depending upon the requirement, I will use the solar system as well as the grid connected system. But after given a time period, what will happen? The investment and the profit made by the system should become zero. Now, in this example, they are showing at 5 years, the returns, the yellow color line you can see, the return in the initial it is zero because we are invested. We don't have any profit. After many years, like 5 years, the returns are equal to the initial investment, that is 4,000 euros or 4,000 rupees. Now, after this years, after 5 years, now I can claim that I am making profit only by the solar energy system. Even though I am using the grid connected system, I am maintaining the solar system, I am also running the auxiliary systems with some different fuels or the electricity. Okay, so once it reaches the zero, that is initial investment minus the total returns into sum. Once it becomes zero, then I can tell it is being profit. Okay, so like that, we are going to see the payback period. So once this payback period is crossing that net zero, then we are talking about this life cycle costs or life cycle savings. So for a given total or over the lifetime period of the system, if you see, okay, the solar system, it is the cumulative solar savings calculated over the lifetime. Lifetime means 25 years or 30 years, whatever, total years of the system, plus the resale value of the system. Say for example, at the 20 years, even after profit, you want to sell it, if any resale is there for the system, that also can be taken into consideration. So if you take all this sum of the costs, then at the end of this lifetime, whether it is profitable or not, then I'm going to tell about that is life cycle savings. Okay. So I'll repeat once again the cumulative savings, that is annual costs or annual savings for a given number of years, 1 to n, minus I have to take initial down payment on the solar system plus cost of the equivalent conventional system if you have gone for that. If that is positive, then cumulative savings are positive. The life cycle savings, as I told you have to consider all the cumulative savings for a number of years. Same thing if you see annual savings, if you take for 10 years, it is also nothing but a cumulative savings only, depending upon the cost of conventional as well as initial down payment. Life cycle saving means here what you are doing is until for a given life, 20 years. For example, 20 years I'm using. So whatever the cumulative savings is done for 20 years, I'm going to find out that. Then after that, if any resale value is there, that is going to add for the life cycle itself. That is the extra saving. So that you have to add with the cumulative saving, or in case of cumulative savings, you substitute the equation of cumulative savings. Okay. So we'll stop the class at this point. Tomorrow we'll discuss some more definitions and we'll take some numericals. Yes. Only 8 members in the class. Okay, what I was focusing is the problems. So what all data can be provided in the question papers? So can you ask some more people to join the Google Meet? Abhishek, Darshan, Fazul Rahman.
So like now we are discussing about third eye portion or overall portion, like for problems of overall portions.
No, overall. For full syllabus, one full syllabus of solar system. So what data can be given? Yes.
Sir, third eye syllabus actually, like most of us are unaware, like we have not gone through it thoroughly. Third eye syllabus.
Just a minute. Third syllabus is what? Which units? Fourth full unit and fifth half. No? Just a minute.
Sir, fourth and fifth, sir.
Fifth is up to concentrating characters only. Just a minute.
What?
Yes, full fifth. Let's see the syllabus here. What is there?
Yes, sir.
It is very simple. Because concentrating character for the third eye, I'm not focusing on the numericals. Only theory part.
Sir, we have fourth chapter and fifth chapter, sir.
No, fifth is half, I think. Fifth is not full. Fifth because the
Yes,
economics is also in
concentrating characters, yes.
yes, all of you please be clear. Fifth unit is half. Okay. Only concentrating characters. Yes, I think air heater is in which unit? Third unit. Okay, I will also see the syllabus. So, fourth unit is on liquid fluid collector and solar air heaters. Solar air heaters is completely 80% theory only. Not some numerical theory. So flat plates, what we call. Nice. From here you have to refer. Flat plate collector theory part. Okay. Then parameter. This is very important question. This will be there in the test or exam, whatever. The parameters affecting the performance of network plate. There are totally 7 parameters. Based on the marks, it will be asked. Okay. And one energy balance equation. On this, I think better to go for numerical. So these parameters will be there. Then we have transmissivity and the absorptivity of the power system, the packet paper. So on this also, theory is very less, but the numericals will be there on this transmissivity of the power systems. This is there. So equations and problems we are called in the class. Then these ones, collector extension, collector parameter. This is only for flat plate collector. And we discussed about the top, side, and bottom losses, depending upon the heat transfer equations, which we have discussed in the class. Okay. And temperature profile between the tubes, between two parallel tubes, how the temperature distribution is there, and how the temperature distribution is there in the length of the pipe. Because we assume that fluid is entering from this end, so fluid temperature is less. Once it enters to the top side, it will be increasing slowly. So this we discussed. Then we have collector efficiency factors and these definitions. This is also very important. Definition of collector efficiency factor, heat removal factor, and flow factor. Okay, this is all about theory part. Then these empirical and mean fluid temperature, I'll just given the relations, but numericals we have not solved on this. Okay, this is just for extra reference. Apart from those equations, which other equations are also used. So this equation why I have taken, because to find out total heat loss. Earlier I told you only the top, bottom, and side losses, but by these equations, so here in the syllabus actually we discussed only the top, bottom, and side losses with simple equations like radiation and convection. But in empirical relation, he has taken comparing all together. He has prepared one equation. This is not there in our syllabus. Actually, this is for extra reference. Then parameters effective of theory. Okay. So this part is there, and in fourth unit is solar aerator. Extension of that is solar aerator. Here we discuss the different types of aerators. These are three types, simple type. Then again we discuss full pass aerators and matrix type or these honeycomb structures or ladder type. Then these type of applications like in agriculture greenhouse types. We discussed the inflatable tunnel, then greenhouse plastic aerator, then UTC. UTC is here, unglazed transparent collector. So these are theory part is there. So I think fourth module we have around 80% theory, 20% numericals. Is that clear? Then in the syllabus we have one derivation on aerators also to write the equation of heat balances on absorber plate, bottom plate, and air plate. These heat balance equations. Okay. Then these problems. Say problems on aerator. I have taken very simple problems. These are nothing but your heat transfer subject itself. Nothing more than that. Heat transfer some data, and if you refer, you come to know how they have solved these problems. Okay. I think these type of problems will be very big. What I have solved here, very big problem. Such step cannot be asked in the 6 or 6.5 months. Okay, that is the other part. Now concentrating collector, the fifth of what I told in the syllabus. This is the part. Solar concentrating collector, theory part. Then the types of the solar concentrating collectors is very important. Classification of the concentrating collectors. This you want to remember. Then different definitions used in this concentrating collectors with some concentrating ratio equations. Okay. Then we discussed the different concentrating ratios for different collectors. We discussed. Then the thermal analysis only this equation. This is the extra part. This to understand how they have taken or how they consider the losses and absorbed energy with this absorber. For that I have taken these image. In this image you can remember the titles. Equations are not required. Is that clear? And how to convert?
Yes, sir.
How to convert a simple flat plate collector to a focusing or a concentrating type of flat collector. In this example, we discuss only this extra angle, that is psi. Psi angle is for the reflector plate. So for the reflector plate, what is the angle to be maintained so that maximum efficiency can be achieved. But here to find the angle, we have one equation, and we are not finding the efficiency using this psi. That is not in these levels. Next is the theory part of cylindrical parabolic collector, working its different parts. And here also you can recall some more definitions: aperture, absorber, concentration ratio. All these things you can explain in this cylindrical parabolic collector. And materials used in this, all concentrating collectors. So these materials also you can recall from the flat plate collector also. Okay, so both the materials for flat plate collector and concentrating collector. Only change is this reflector is the new part. Reflector is a different part. It may be a metal, it may be a glass or a plastic reflector. Depend on the paper. Okay. And later we solve this example just to understand how the calculations will be done on concentrating collectors. Okay, this one simple example I have taken. Only two-step problem. One is to find out useful interval. One is to find out output temperature. Is that clear? This is for the third eye syllabus. Solar economics is not there in the third eye syllabus. Is that clear?
Yes, sir.
Okay. Now coming to, do you have any other class now? Are you free now or you have any class at 1 p.m.?
Sir, I guess we have class
From 1 p.m.
Till 2, like 1:50, sir. Then afterwards.
Then what we'll do is tomorrow we'll discuss about the SWE paper and its data, what to be given. Okay.
No problem.
Yes.
Yes, sir. No problem, sir. Like we'll discuss tomorrow.
Okay. Tomorrow we'll discuss them.
Okay, sir.
Tomorrow or else in after third I also can discuss. But provided if you
Sir,
finalize now,
like
it's possible for the final decisions what to be taken from the department to discuss. I think tomorrow we'll finalize that.
okay,
Okay.
sir.
Okay, thank you.